You ever wondered if we could transform Mars into a second Earth? It's a question that has fascinated scientists and dreamers alike for generations. Mars, often called the Red Planet, shares some striking similarities with Earth, like the presence of polar ice caps at a day length just over 24 hours. Yet, it's also vastly different. Its thin atmosphere is mostly carbon dioxide, and surface temperatures can plunge to a bone-chilling -80 degrees Fahrenheit. With the growing interest in space exploration and colonization, the idea of making Mars habitable is more tantalizing than ever. In this video, we'll delve into the exciting possibility of terraforming Mars. We'll explore whether it's scientifically feasible, the technological challenges we would face, and the incredible benefits it could bring. Imagine standing on a warm green Mars, breathing fresh air under a blue sky. It's a vision that might not be as far-fetched as it seems. So, what exactly is terraforming? In simple terms, it's the process of transforming another planet's environment to make it more Earth-like, suitable for human life. Currently, Mars is a harsh place. Its atmosphere is thin and composed mainly of carbon dioxide. Its surface is barren and rocky, and liquid water can't exist for long due to low atmospheric pressure. But what if we could change all that? Let's find out how close we are to making this sci-fi dream a reality. To understand the feasibility of terraforming Mars, we first need to grasp its current state. Mars' atmosphere is incredibly thin and composed mostly of carbon dioxide, with only trace amounts of oxygen and water vapor. Surface conditions are equally harsh, with temperatures averaging around -80 degrees Fahrenheit and high levels of radiation due to the lack of a protected magnetic field. However, there is hope. Water exists on Mars in the form of ice, particularly at the poles and beneath the surface. For Mars to become habitable, several critical changes are needed. First, we would need to thicken the atmosphere to retain heat, and be essential to create breathable air for humans. Additionally, stabilizing liquid water sources would be crucial for sustaining life in agriculture. So how could we achieve these monumental changes? One method involves releasing greenhouse gases to warm the planet, mimicking Earth's own climate change, this time with positive intentions. Another idea is to use giant mirrors or other technologies to reflect sunlight onto Mars' surface, gradually increasing its temperature. There's even talk of introducing hardy microorganisms that could help produce oxygen and break down the soil into more fertile ground. While these methods are still theoretical, they offer intriguing possibilities for turning Mars into a second Earth. While the idea of terraforming Mars is thrilling, the engineering challenges are monumental. Transporting materials and equipment across millions of miles of space is no small feat. Imagine the energy requirements for large-scale projects like warming an entire planet or creating a breathable atmosphere. Then there's the challenge of building sustainable life support systems that can function autonomously in Mars' harsh conditions. The time frame for terraforming Mars is another daunting aspect. Estimates range from centuries to millennia, making it a project that would span countless generations. The scale of operations needed is mind-boggling. Transforming an entire planet isn't just about scientific innovation. It's about sustained effort, resources, and international cooperation on an unprecedented scale. We also need to consider the ethical and environmental implications. Altering Mars' ecosystem raises significant ethical questions. Do we have the right to change another planet so drastically? There are also potential unintended consequences to consider, not just for Mars, but for Earth as well. Could our actions on Mars have unforeseen effects on our own planet? These are complex questions that need careful consideration as we move forward with such ambitious plans. Navigating these technological challenges will require not only advanced engineering but also thoughtful consideration of the broader implications, ensuring that our efforts to terraform Mars are both feasible and responsible. Terraforming Mars could be a game-changer for humanity's survival and expansion. By creating an alternative habitat, we would have a backup plan in case of catastrophic events on Earth. This new frontier would also provide unique opportunities for scientific research, allowing us to study planetary sciences, biology, and even human adaptation in entirely new ways. The economic benefits of terraforming Mars are also enticing. Mining Martian resources could open up new markets and create unprecedented economic growth. Imagine the job creation in space industries and related fields, engineers, scientists, construction workers, and more, all working together to build a new world. The potential for economic expansion is enormous. Beyond the practical benefits, the sheer ambition of terraforming Mars can inspire future generations. Projects of this scale capture the imagination and drive innovation. Young scientists, engineers, and explorers would grow up with the dream of contributing to humanity's next giant leap. The cultural impact of becoming a multi-planetary species cannot be overstated. It would redefine what it means to be human and our place in the universe. From ensuring our survival to sparking economic growth and inspiring future generations, the potential benefits of terraforming Mars are as vast as the cosmos itself. It's a vision that pushes the boundaries of what's possible and invites us all to dream bigger. As we've explored, the idea of terraforming Mars is both fascinating and complex. Scientifically, we understand that Mars' thin atmosphere, freezing temperatures, and lack of liquid water pose significant challenges. However, potential methods like releasing greenhouse gases and using reflective mirrors offer promising solutions. The technological hurdles are immense, involving massive energy requirements, transportation logistics, and ethical considerations. Yet, the potential benefits, ensuring human survival, economic opportunities, and inspiring future generations, make it a compelling pursuit. Now, I want to hear from you. What are your thoughts on terraforming Mars? Do you think it's a dream worth chasing, or are the challenges too great? Share your thoughts in the comments below. If you enjoyed this deep dive into the possibilities of making Mars Earth-like, don't forget to hit the like button and subscribe for more content on space exploration and other scientific topics. Together, let's keep exploring the final frontier and pushing the boundaries of what's possible. Thanks for watching.